Hello there. Welcome back to the series of video lectures on engineering mechanics. To understand the better, please follow the series of video lectures so that your understanding capabilities are going to be increased a little better. Right? So in this connection, I'm going to be trying to solve one more the variety of the problem here. So there we have seen the objects are moving in the horizontal direction, the objects are moving in the inclined positions, and the objects are moving, one is the vertical, one is the horizontal direction, right? One is the horizontal and the vertical directions. And now is another type of the problem is that the pulley is going to be hanged over here and two weights are going to be connected with the string. These two are moving in the, one is upward direction, one in the downward direction. So now I'm going to read out the two blocks of weight W1 and W2 are connected by a wire passing over the smooth pulley. In this case also the friction between the rope as well as the pulley is going to be 0 and the two weights are going to be connected. If W1, so the W1 is greater than W2, this is the condition he has given. Find the acceleration of the system and the tension in the string. So that means we need to find out A1 and A2 and the tension we need to be calculated. So in this case, any numericals are not provided. That means the value of W1 and W2 is not provided. So that we are going to be deriving that equation and we are finding the A1, A2 as well as the tension in that string we need to calculate it. So here we will draw the free body diagram. So as we know, W1 is going to be greater than the W2. So I am assuming that on that basis the object is going to be trying to move in the downward direction. When it is moving in the downward direction, that's motion, then what about this body? That's going to be trying to move in the upward direction. This is the motion I am assuming. Right? Once the assumption is completed, then I will draw the free body diagram for this part. That's going to be, this is going to be the self weight is always acting in the downward direction. This is your W1. The tension is always acting in the upward direction, or I can say that T is going to be your tension. So when the object is moving in the downward direction, there is an uninvented force is going to be there. That means it is not, no need to give an invitation. Automatically that force is to get into the picture. That's going to be the inertia force. When the body is moving in this direction, your inertia force, that's going to be Fi1 is going to be acting in this direction. This is your motion. So I am going to be writing the equation sigma f of y is equal to 0. So in this case, that formula, the T and F1 is going to be acting upward direction. This is acting in the downward direction. If I am going to be simplifying this equation, T, this is going to be your M1 A1, the W1, so this is the equation 2, and similarly I am drawing for the W2 also. So this is going to be self weight is acting in the downward direction, the tension is acting in the upward direction, but the motion is going to be in the upward direction for this part. This is your motion and the inertia force is going to be acting in the downward direction. And similarly for this also I am going to be taking sigma Fy is equal to 0. Then these two forces are in the downward direction. P is equal to F12 plus W2. Further simplifications of this equation, the T is equal to M2 A2 plus W2. This is going to be, I am writing W2 by Z A2 plus W2 is going to be your equation. And T is plus, suppose T is equal to W1 minus W1 by Z into A. Can you see? This is the equation 1 I am shifting from this. After the simplification, from these two equations, we need to find out the tension in the string, acceleration A1, A2, we need to be calculated. So in these equations, can you see A1 and A2 is going to be available, at the same time the tension also not available. It means that in this case the two equations, three unknown parameters are there. For the simplifications, I am going to be assuming if A1 is equal to the A2 is the A. In this case, acceleration which is moving in the upward direction and the downward direction, I am assuming the constant. So then I am going to be simplifying this equation. A1 and A2 is going to be like this. And addition and subtractions we are going to be doing minus, minus, minus. So then this parameter will going to be 0. And further simplification, 0 is equal to W1 minus W2 minus of, in this case what we are getting, W1 plus W2 by Z into A, I will get it. Further simplification from this equation, A is equal to this parameter, suppose you are taking to the right side, so then W1 minus W2 by W1 plus W2 by Z. And further simplification, A is equal to W1 W2 Z by W1 plus W2. So can you see the acceleration, I got it, W1 minus W2 into Z divided by W1 plus W2. This way we are going to be calculating the acceleration. Once if I am going to be getting this acceleration, I will substitute any one of this equation so that I can get it the tension in the string. Now I am substituting in the equation 1 over here. That's going to be T is equal to W1 minus W1 by Z into W1 minus W2 divided by W1 plus W2 into Z. Z will going to be cancelled out, right? The T is equal to W1 minus W1 W1 plus W2. So if I am going to be simplifying this equation, so the simplification will come in this way. That will be W1 minus of W1 minus W2 by W1 plus W2. And further simplification, I am going to be taking the LCM. That's going to be W1 plus W2 and minus of W1 plus W2 divided by W1 plus W2. So in this case, W1 and the W1 will going to be cancelled out, and here the two W2 we are going to be getting, that's we are multiplying with the W1. So and that equations I am going to be writing over here. So that's going to be T is equal to 2 into W1 and W2, W1 and the 2 W2 divided by W1 plus W2. This way we are going to be calculating the tension in the string, and acceleration is equal to W1 minus W2 into Z by W1 plus W2. And the same I am going to be substituting in the equation 1. I got it. T is equal to 2 W1 W2 by W1 as well as the W2. I hope you are able to understand the degree of difficulty in this problem. So when it is going to become some of the parameters we need to assume, because those parameters, the data is not available ready-madely. But if you need to come to that, we need to have such a thought process. That means we are learning how to think and how to solve this problem over here. So this way we got the answer of the tension as well as the acceleration. I hope you people are able to understand. Still, if you feel any difficulty in this concept or in these fundamentals of this equation, this problem, please put in the comment section so that I will try to answer further questions. Thank you. All the best.